them out.
はい。じゃあちょっとですね、日本語でご案内。はい。ちょっと今までオンラインの登壇が続いたんですけれども、ここからですね、オフラインでのリアルでの登壇がちょっと続きます。またちょっと先ほどとは変わった形になりますので、ちょっとよりリラックスして、はい、臨んでもらえればなと思います。で、ネクストセッションのタイコなんですけれども、ちょっと冒頭にもご案内したんですが、タイコさんがホストとしてですね、イースグローバル東京のアフターパーティーをアキンドとしてもサポートさせていただいております。こちら4月16日、イース東京グローバルが終わった直後ですね、もう本当に直後のアフターパーティー、日本名で虎ノ門横丁ハッカー祭りというような形でやろうと思ってますので、はい、皆さんこちらもチェックしてみてください。Okay, thank you so much. Are you ready, Dave?
Yes, I am.
Okay, じゃあ、so please presentation, go ahead.
All right, konnichiwa. What's up, everyone? I'm super excited to be here in Tokyo. It's great to be here and to meet all of you builders. Like, we really want to help you guys out just to build on Ethereum, essentially, because Ethereum's awesome. So, I'm going to be talking about Taiko, which is a ZK rollup. It's kind of an interesting one, and let's just get right into it. So the topics of discussion that I'll go through is, first I'll just give a background on Taiko. I'll explain like what are we in terms of where we're at right now, and I'll also talk about where we're going with our protocol. All right, so a little bit of a background on Taiko. So we are scaling Ethereum with a type 1 ZK EVM. Does anyone know what the ZK EVM types are by any chance? You can like raise your hand if you do, but maybe not. Okay. Cool. So basically, ZK EVMs can be classified into different types based on how compatible they are with Ethereum, right? So we are a type 1 ZK EVM, which means that we are the most compatible with Ethereum. It's actually considered Ethereum equivalent. So we'll talk about that a little bit more. The ZK EVM effort is a community one, actually. We work with the Ethereum Foundation's privacy and scaling team, along with Scroll, on building the ZK EVM circuits library. And this is to be able to prove Ethereum blocks as they are today. A little bit more background. We have several team members that come from Loopring, where they built the first ZK rollup on Ethereum. So we definitely have a lot of experience with rollups. We have around 25 people now, and we'll have 20 here in Tokyo, actually. So come say hi at like the ETH Tokyo event. We're down to like chill and just talk. So a little bit more about us. Like I said, we are a type 1 ZK EVM. Another interesting aspect is we are totally open source and MIT licensed. So that's really everything. Like our protocol, all of the smart contracts, everything is on our GitHub for you to contribute to and read about our protocol design. That also kind of implies that we are a community developed and driven project. There's no like permissions in using Taiko. There's no permission to block proposer. There's no permission to prover. Anybody can run the Taiko network, propose blocks, prove blocks. It's not like owned by anyone. We have 55,000 community members on Discord. And our last testnet, we had 2,000 people running the node software and proposing blocks, and we had 140 unique provers in this testnet. So we had an Alpha 1 testnet where we had block proposing that anybody could do. In the Alpha 2 testnet, we had proving that anybody can do, but a single proposer. And in Alpha 3, we have some other stuff, which I'll go over. Okay, so I want to get back to this Ethereum equivalent thing because I know that we've been talking a lot about like rollups and scaling, and like it's a lot to go through. So let me try to put it in this perspective, right? So if you look at this chart here, there's like you can go from type 1 to like type 4. This is kind of like Vitalik wrote a post about classifying ZK EVM types, where you can kind of your ZK EVM can be on a spectrum of having high compatibility or having like higher prover performance. So we choose to like maximize compatibility and not change anything about the rollup that would make it easier to generate faster proofs. So an example of like maybe one thing that could generate faster proofs is if you use like a custom VM, right? Like ZK Sync or something like that. But we still use the EVM. We still use the same hash KCHAC 256 hash function. We use the same Merkle-Patricia tree data structure. In fact, we just use Geth, which is a Ethereum execution client, and we fork that library and just or that code, and we just make very small changes to it for our protocol. But when you use Taiko, it essentially just looks like you're using Ethereum because it's this type 1. So this next point I have here is like, what is a rollup, right? And I think it's an interesting question, like what is it really? And I would say that it's kind of a state machine, just like Ethereum is, right? Like Ethereum is a state machine. A rollup is also a state machine. You're just going from one state to another state, and to get from one state to another state, the inputs are some transactions, right? To define the next state. And for our, the state transition on Taiko is the same as Ethereum. In the Ethereum yellow paper, there are validity rules which define the state transition function on Ethereum, and we use that same function in validity rules on Taiko. So yeah, also like a rollup is something that you can build from some base layer, right? So we rely on Ethereum as the base layer for the data availability. So you can always build Taiko's state just by examining the contract which is deployed on Ethereum. Yeah, and like I said before, we just reuse a Geth execution client. Everything's the same: gas costs, state trees, the hash function. One really cool thing about this as well is like if you think about how bridging would work on a really like elegant protocol like this, you can literally just use Merkle proofs. So like if you're on, let's say, Ethereum or you're on Taiko, all you really need to do if you want to bridge some data over from Ethereum to Taiko is to just present a Merkle proof that that state was included on the source chain. And because the destination chain, in this case it would be Taiko, uses the Merkle-Patricia tree to create blocks, it's simply just verifying a Merkle proof to send a message. So it's like I don't like the word trustless, but it's an extremely trust-minimized bridge where you don't rely on anyone. You can just use Merkle proofs yourself, call an Ethereum node, just say get proof, like ETH get proof, present the Merkle proof to Taiko, and then you can securely bridge over some type of data or funds. Yeah, and again, like Taiko is like actually more of like a platform for building. We don't even consider a bridge like a part of the Taiko protocol. A bridge is just like an application that's built on top of Taiko, and anyone can come and build a different bridge. Okay, overview of current protocol design. So I'm just gonna like kind of breeze through this, but kind of show like how the protocol works, right? So like down here you have the users, and they're submitting transactions on the rollup, right? Like the rollup is just all of these nodes. Everyone is running nodes, and people are submitting transactions to that mempool. And then also, actors within Taiko can run a version of the node software, which makes them a proposer. So they can select transactions out of that mempool and propose them to the layer 1 smart contract, which governs like what the state of Taiko is. So they go ahead and they propose a block. There's like these slots that exist on the layer 1 contract. So you can see here in blue, this is a block which is proposed, right? And you see here, I put in parentheses at the top that it's deterministic. I know instant finality is like also a common word, but basically, what I'm trying to say here is when you propose a list of transactions to the layer 1 contract, we have very well-defined validity rules to compute the state transition for the rollup. And we just derived that from Ethereum. So as soon as you get the list of transactions and it's proposed, anybody can compute the rollup's next state. So you can just move on immediately. You don't even need to wait for a proof. So that's why we kind of prioritize compatibility a lot, because we see proof generation time kind of going down, and people can still continue on the rollup because you can deterministically get the next state of the rollup, right away. All right, yeah, so you propose the block, and then prove a block. Yeah, so proving a block is just proving that you went from one state to the next state, and everything was done in a valid way. So you need to present like a validity proof or a snark. You present that to the contract, and this block can become proven, right? But keep in mind, this is just proving one state transition to another one. But you don't know if the parent is proven yet, right? Which is why we have a third state, which is verified. So verified is like when all of the parents from Genesis are proven to have had valid state transitions, then you know that the current block has had like a valid proof for you to move forward. And this is like some of the, like I said, you can continue on the roll up without a proof, but you might want to have a proof for things like bridging out of the roll up. Yeah, so constructing the rollup state, I kind of touched on this earlier. It's like right when that transaction list is proposed, you can just start building Taiko's state like immediately. No need to wait for a proof. Yeah. This is just kind of like an overview of what I just went through, like the steps. Okay, I want to talk a little bit about where Taiko is going with the Alpha 3 testnet. So we're simplifying the protocol with some major optimizations and features. So like I said, when you propose some transactions and we do some validity checks to figure out what the next state of the rollup is going to be, we're moving a lot of that logic out of like layer 1 and just putting that into like zero knowledge proofs that the nodes can do. And this will make the fees a little bit cheaper for users and simplify the protocol a little bit. We're also going to enable EIP 1559 on the L2. And we have this, one thing I didn't touch upon like as much is how like Taiko is like this fully decentralized, right? Like anyone can prove blocks. There's no centralized sequencer. Anyone can propose blocks. It makes for a really interesting tokenomics kind of problem for us, right? Like kind of a fun challenge, actually. So, one of the things that's coming next in our next testnet are these EIP 1559 inspired fee structure for charging proposers and also giving rewards for people who generate proofs on Taiko. We're going to apply some lessons learned from our last testnet, like on contract upgradability. And I put one other interesting point here, which is like, does prover decentralization matter? And I think it's I think it's an interesting question where it might not matter as much as having permissionless prover network, because the real important part of the decentralization is kind of like on the consensus layer, which we rely on Ethereum for that. On the proving layer, it might be okay if there's just a few entities but anyone can join and they can go ahead and like prove blocks. We're also going to have some more circuits done, get closer on the roadmap of the ZKVM circuits, and moved our code base to using Foundry. Long term, the community needs to finish the circuits to prove Ethereum blocks as they are today. And like I said, we're kind of working collaboratively with that. I put Enshrined Rollup here just because I feel like Taiko would probably be the best candidate for that as a Type 1 ZK EVM. EIP 4844, which is proto-dank sharding, is something that's exciting for all of the rollups. And then also we're going to make some progress on these roll-up training wheels. And if you don't know what that is, you can just Google like roll-up training wheels. There's a post by Vitalik on this, on like how we can make roll-ups more mature and more secure. So we're going to try to make improvements on that as well over the long run. Let's see here. Resources to build on Taiko. So yeah, I know a lot of you are here for the ETH Global Tokyo event, and I'm sorry to say that dApp development on Taiko is very boring because it's literally the same as just building on Ethereum. So any Ethereum tutorial, like no questions asked. You don't need to be like, oh, but like, do I need to change this? Like, can I use the transfer function, or can I use like will the block hash like be based on like a Merkle Patricia tree? It's just the exact same. So you can just develop like you're developing for Ethereum, change the RPC like you would for like a testnet or something, and you're good to go. There's several guides available at taiko.xyz on how you can start building here. I also made like, you can like go to my GitHub repo. This is called like dApp slaps. And if you just click this blue button, this one click, you'll have like a dApp, which you can just start like hacking on. I'm going to try to make this support like a lot of networks, hopefully, before ETH Global Tokyo starts. But you could think of this as like, this dropdown could have like Taiko, Optimism, Scroll, like anything really, right? All these EVM equivalent chains. But yeah, I made this. Hopefully it helps you guys to just get started building in like one click, I guess. And you can check that out. And then also feel free to come help build Taiko itself as well. Like you can come look at our repo. Like I said, we're fully open source MIT licensed. We have a contributing guide, and we are happy to collaborate. And then yeah, we have like 20K USD in prizes for ETH Global Tokyo. We're like one of the major sponsors. So yeah, come get some money. Yeah, here's some QR codes. You can follow us on Twitter, read the docs. These are the slides. And yeah, thank you so much. Open for any kind of questions.
All right, thank you so much. It was very fun. So if you guys have any question, please raise your hand. I actually got 2 questions online too. So first one is, actually this is not question, it's more like a requesting, but he or she wants to see your shoulders, the pictures.
Oh, this?
Yeah.
All right. Yeah.
There's a camera right there. Maybe, yeah, people
All right.
can check it.
Yeah.
I have a question about that. Why is Taiko? I mean, like, why did you name your project Taiko? Is it like Japanese Taiko, or it just...
Yeah, there's like a Chinese story as well, but it's like a combination. It is related to a drum, but there's like I can't remember exactly what the quote is, but it's based in like the beat of a drum, and also just kind of like just doing our best effort to like kind of like complete something that's really ambitious and difficult. So yeah,
That's very nice. Thank you. So another question that we have for you is, what is the important point of choosing roll apps? There are so many types of roll apps or layer 2, and it's getting more complicated. That's the question.
Yeah, so the most important choice, it depends on what you're trying to do. If you're just at a hackathon and you want money, just deploy to like whatever rollups and do that. But in terms of like user security, which is very important for everyone, right? You need to you need to be careful about the security risks. There's like so many different ones. Like it would be hard to go through all of them. But like, let's say you even had like perfect ZK EVM circuits, right? If there's a bug in your client, in your execution client, like you're using Geth or something like that, if there's a bug in that, you're just proving something invalid anyways. Like that's one bug that could come up. Another bug is just the ZK EVM circuits are broken. So like, you know, you might need to have like some diversity on the proof system, diversity on the execution clients. There's all these security risks. So like, I mean, I don't mean to like to like just shill Taiko or anything, but I would stay on the side of high compatibility. Because it'll give you easier time as a developer, but it'll also give you more like a better feeling of trust that something won't go wrong. Because otherwise, you need to make all these considerations like, will this work in the way that I expect it to? So I would say try to stay towards, just my opinion, like more EVM equivalent. Maybe Ethereum equivalent is best. That would be kind of my opinion on it.
Nice, thank you so much. I have one quick. I mean, not me, but like there's a question online. So Taiko is type 1 ZK EVM feathers. Other types of layer 2 are also available. Do you think they will coexist, or will they eventually be battled? That's a question.
Wait, there will eventually be a what?
Eventually be a battle.
A battle.
Yeah.
I see. I feel that there will. I feel that we're going to migrate more towards EVM compatibility or Ethereum equivalent kind of things. And the reason why I feel that way is if you look around, you'll see there's so much progress. Even if you don't like the EVM, like I know there's things to complain about the EVM, but even you can't deny that so much work is being done on Solidity, the EVM, like things like Foundry. I think a lot of work is being like done to support this kind of developer community on Ethereum. So I would kind of bet on the EVM compatible side. And I do see for some reason like there being like multiple rollups existing. Like it's difficult for me to imagine just one being there because all the teams are going to be trying hard, and I can imagine there being multiple ones, which makes all of this cross rollup communication work really interesting too.
All right, thank you so much. We got another question. Taiko members are from Loopin, the same ZK rollups. Why was Taiko developed?
Yes. So the reason for Taiko being developed is because we wanted to make like a general purpose ZK rollup, and Loopring was kind of set out to be more of like an app specific ZK rollup. So I believe at Loopring they're kind of maybe going more for this like app specific rollup or layer 3 path, where Taiko's focusing more on a general ZK rollup for people to use.
I see. Thank you so much. So
Okay.
is there any other questions here? If not, then yep. Okay. どこ?
I have one question. What kind of dApps do you want on Taiko?
All of the dApps.
All of that.
No, but what's I think bridging is really interesting. Like also, but really like all kinds of dApps. We want people to just come to it, and you don't need to think like it's a lot of friction to come to Taiko, because if you just develop on Ethereum, like you just develop on Sepolia testnet, migrating to Taiko is simply just changing one URL and then you're there. So I would just think of let's develop for Ethereum, and then Taiko will just help Ethereum scale. So, but really it's just let's just develop on Ethereum and what's cool for Ethereum. And again, like I think bridges are cool in this rollup space. I'm just gonna give a little bit of an extended answer. Because we have like these totally decentralized nodes and like provers that people can run, kind of like on Ethereum, we hope to see like some progress in making it easy for the community to just run nodes. They can like earn some money, they can become like a prover. Maybe it'll be like this like new like mining era for like generating proofs. So I think improving that software is another type of application for Taiko.
Thank you. Thank you
Yes,
very much.
thank you.
Thank you for your question and your answers. Thank you so much. Any other questions? Okay, so thank you so much for your speech. And I think it was the first in-person speech today. Yeah,
Oh,
that was
oh,
very
yeah.
fun. Thank you so much.
Okay, arigatou gozaimasu.
ありがとうございます。
Thank you so much. はい、じゃあここからですね、ちょっと10分ほど休憩の時間を取りたいと思いますので、4時 5分からまたスタートしたいと思います。